Our final problem on this exam is a synthesis problem. And as we know, we always want to approach these in reverse. And so the first thing that stands out to us in this question is that we have a nitrile right next to an OH group. And we don't have a lot of ways that we can form nitriles. They either need to be formed through a substitution reaction or through an opening of an epoxide is the other common way we've seen to form them. And given that this one happens to be directly next to an oxygen, it's very feasible that we could have made this by opening up this epoxide. Now, if we're going to use that epoxide, we need the attack to take place at the less substituted carbon, but we can do that just by choosing basic conditions for our ring opening. Now, an epoxide we know that we can make from an alkene, so we could assume that this compound would come from the corresponding alkene. And if we're drawing the forward direction, that's the alkene plus MCPB BA. Now here it's a little bit more challenging. We have this alkene that we need, but we also need to add in some carbons. And the easiest way we have to add in carbons is using a Grignard reaction. So if we go forward from the beginning, we add magnesium. That'll make our Grignard reagent. We need to add a total of 3 carbons. And so we can put the oxygen in the middle. To get that intermediate. And then the only thing that separates us between that intermediate and where we need to be is an elimination. Now, alcohols don't always eliminate easily, but in this case, it's a tertiary alcohol. All we need is some acid, and that will easily eliminate to get us the alkene and complete our synthesis.